Okay, so let us continue with chapter 3. So we have two more questions to go. If we can finish earlier, then I will let you guys go earlier. So these two questions, both of them, they are two-dimensional questions, 2D questions. Now, what does it mean by 2D questions? When it comes to 2D questions, it means you need to resolve it into x and y component. So let's look at the questions 5. Okay, questions 5. Now a ball, okay, a tennis ball of a mass m1 moving with an initial velocity u1. You are not given any informations about the mass and also the initial velocity yet. So it collides with a soccer ball of a mass 2 that is initially at rest. So once again, you have the keywords m2 initially is at rest. So after the collisions, the tennis ball deflects 50 degrees from its initial direction as shown in the figure. So given m1, okay, so now you have m1 equals to a 250 gram, m2 equals to 900 gram, u1 initial velocity is a 20 meter per second, and then v1 is equals to 4 meter per second. Calculate the magnitude and the directions of the soccer ball after the collision. So what happened right now is, now you have a m1, okay, before collision, m1 equals to 250 gram, and then your u1 given is 20 meter per second. Now, for me personally, I like to write down all the informations in my diagram to make it easier for me to see what is the information that I have and what is the information that I don't have. So m2 now is equals to 200, and now, sorry, m2 is a 900 gram. Okay, it's 900 gram, and then my u2, now u2, because initially my object is at rest, therefore it is equals to 0 meter per second. Now it seems like I have all of the informations right, but that is not the end yet. Okay, because we have a object after collision. So after collisions, what do I have? I have a still m1 equals to 250 gram. My my v, final velocity, v1 is now equals to 4 ms negative 1. m2 is still 900 gram. Okay, now if you look at this diagram, the thing that is missing is v2. So what is the values for v2? Now, how are we going to solve this question? Okay, obviously, you have collisions, you have before collisions, and then you have after collision, which means you are going to apply principle of conservation of momentum to solve this question. But then, how are we going to solve it? This is a two-dimensional questions. When it is a two-dimensional questions, you need to solve it according to its component. Okay, you calculate the conservations according to its component. So first of all, what am I going to do? I'm going to calculate the informations along the x component. So x component, what should I write? If you remember what I told you in the previous lesson, always begin with the principal. So summations p, p initial x or initial xp. Okay, it's up to you. So p initial x, or you want to write px initial also can. So initial momentum along the x component equals to summations p final x. So which means what are you going to check? What are you going to do is you want to calculate the momentum along the x component only. So initially, what happened? Initially, I have the motion along the x component only. So which means I don't have to do anything. I don't have to resolve it or what. So what I'm going to do is just, okay, for initial part, I have m1 u1 plus m1 v1. Okay, I don't have to resolve it. Oh, sorry, not m1 v1, m2 u2. So initially, I don't have to do anything. I don't have to resolve it. Why? Because my initial momentum that happens before collision, it just happens along the x component. All right. But then after collision, what happened? If you look at the diagram, after collision, now this is my x-axis, this is my y-axis. So my object is now moving in between x and y-axis, which means I need to resolve its velocity, all right, to calculate p along x component. So p1x, and then the p along y component, p1y. So what does it mean by p1x? p1x is m1 v1 along x component. p1y is equals to m1 v1 y along y component. So since I'm looking at the x component right now, so what am I going to do here? I'm just going to write it down as I'm just going to write a p1x here. So m1 v1x. Okay, so the momentum along the x component, the final momentum for object 1 along the x component. And then plus, now since m2 is an unknown, okay, what we do know is the mass, so m2, but we don't know about its velocity. So what are we going to do? Okay, we can write v2x first, because we don't know whether it's moving along the x component, it's moving along the y component, or it's moving in between x and y component. We don't know what is the direction, all right? And we don't have the magnitude. So what can we do? We just write it down, okay? We just write it down as 2x in case it has an x component, in case we need to resolve it, right? So now I have m1 u1, m2 u2, and then m1 v1x, m2 v2x. So what am I going to do next? I'm going to substitute the value. Now, do I need to change the mass into kg? For instance, if you look at the m2, no. All right, because now all 4m, your m1, m2, m1, and m2 in the equations, all 4 of them, they are all in gram. So you don't have to change it into kg. So that is what I explained it to you in a previous lesson. In the law of conservations of anything, conservations of momentum, conservations of energy, conservations of charge, and so on, if the symbol on the left-hand side is equal to the symbol on the right-hand side, the unit, okay, the unit on the left-hand side is the same as the unit on the right-hand side, then you don't have to change the unit. Okay, you don't have to change it into SI unit. But if they are not the same, for example, if you have a M1 is gram, M2 is kg, then you must change everything into same unit. All right. So now let's plug in the value into the equations. 2250 times 20 plus 900 times 0 equals to M1 is still 250. Now V1x, so what am I going to do with V1x? I have V1 equals to 4. So 4 cos 50 degree. And it's going towards the positive x direction, therefore it is a positive value. So plus M2, now I have a value which is 900. And then V2x, okay, V2x. So this is the second line. And then if you solve the equations, if you rearrange the equations, eventually you will obtain V2x equals to 4.84 meter per second. All right, 4.84 meter per second. So this is for x component. All right, this is for x component. And now I'm going to repeat same thing for the y component. Okay, so y component, pay attention. It is a difference. Okay, it is quite different than the x component. So P initial along y component equals to summations P final along y component. So again, I'm just going to rewrite the equations. M1, now I'm not going to write the front part, the initial. Why? What should I write for the initial? So if you look at the diagram, the reasons why I didn't use subscript x for initial x is because I know the object is moving along x component. So if you look at the first diagram, the diagram before collision, okay, the diagram before collision, object is moving along x component. There's no y component, which means when it comes to y component, actually you can just write 0. So 0 equals to M1 V1Y plus M2 V2Y. So the reasons why I can write 0, because the diagram shows clearly that there's no X component before collision, right? There's no X component before collision. And then a Y component for final collision, yes, we do have. By looking at the diagram itself, V1 is moving in between X and Y component. So P1 itself already have a Y component. Therefore, for momentum, total momentum after collision, we need to resolve it. That's why if you look at my equation, I have 1x, 2x, 1y, 2y. Because after collision, there's a two-dimensional motion. Okay, it is a two-dimensional motion. So what am I going to do now? Again, I'm going to plug in the value. So 0 equals to M1 is 250 degree. Now, if you look at V1, okay, V1 final. After collision, my P1Y is pointing downwards, in which it means my V1Y is a negative value. So you must include this negative value. Okay, you must include this negative value in the calculations. So I have a negative 4 sine 50 degree plus 900 V2Y. Okay, 900 V2Y. So rearrange the equations, you will get V2Y equals to 0.851 ms negative 1. Okay, 0.851 ms negative 1. Now that you have a V2x and V2y, you can then calculate its resultant. So V resultant is equals to square root V2x squared plus V2y squared. Okay, so you substitute the value and eventually you will get the answer, which is a 4.91 ms negative 1. Once you have the magnitude, you can then determine the direction. Okay, so direction, theta equals to tangent negative 1. Now I have a V2y over V2x. So if you solve it correctly, you will get a 9.97 degree. And then if you look at the value for V2x and also V2y, both of them, they are positive. Okay, what does it mean by positive? If x and y both are positive, it means my angle, this 9.97 degree, is located in above, okay, in the first quadrant. So above positive x-axis. All right, because I have positive V2x and I have positive V2y. Therefore, my final vector, the resultant vector, is located in the first quadrant. All right. So this is questions. Okay, questions. Yeah. Okay. This is questions 5 for you, sorry. So questions 5. So write down first, and then the last part, you should be able to solve it by yourself. Now, I'm going to show you an alternative method. Okay, don't copy yet, all right? I will give you time to copy it down. So right now, I want you to pay attention. Now, sometimes what students do is that this method, okay, this step, okay, this step, students will write it as 250 and then times 20 plus 900 times 0 equals to, Okay, equals to what? Equals to a 250 and then 4 cos 50 degree plus 900. Now V2x, sometimes students will write it as V2 and then cos theta 2. Can you leave it like this? Yes, you can. Then if you rearrange the equations, what are you going to get? You're going to get V2 cos theta 2 equals to 4.84 meter per second. So this would be our first equation. Okay, this would be our first equations. And then what happened next? So when students, they did the calculations for y component, this step, they then write it as 0 equals to 250 negative 4 sine 50 degree plus 900 V2 sine theta 2. Now, can you do like this? Of course you can. So once again, if you rearrange the equations, what are you going to get? You're going to get V2 sine theta 2, which is equals to 0.851 meter per second. Okay, so these two equations, basically they are the same. Why? Because V2x, okay, wait, let me change the color. Because V2x is equals to V2 cos theta, and then V2y is equals to V2 sine theta. So basically they are the same. Just that when it comes to the second method that I use, as shown on the left hand side, what can I do? How should I solve the question? Now I have equations 1, I have equations 2. All right. So what am I going to do? Now I want to use equations 2 divided by equations 1. All right. So which means I will have V2 sine theta 2 divided by V2 cos theta 2, which is equals to 0.851 divided by 4.84. Right? So what happened on the left hand side? When you have a V2 and V2, you can cancel it out. Sine theta divided by cos theta, it gives us tangent theta. Okay, tangent theta. So tangent theta equals to 0.851 divided by 4.84. So from here you can get the angle, which is equals to 9.97 degree. So you obtain the angle first. So from angle, you then calculate the V2 by using either one equations. You can use equations 1 or you can use equations 2. So let's say I use equations 1. So from equations 1, I have a V2 cos 9.97 degree equals to 4.84. So V2 equals to 4.91 ms negative 1. Right? So this is how you determine the value. So you then check with the, okay, you then look at the equations 1 and 2 again. V2 cos theta is positive value. V2 sine theta again is positive value. So we know angle is above positive x-axis. Right? Above positive x-axis. So you need to know both methods. All right? You need to learn both methods because sometimes questions might need you to apply the second method. Okay, it might need you to apply second method. So now I give you 5 minutes to write it down. All right, 5 minutes for you to go through it to write it down. Okay, so boleh catat kedua-dua method Anda kena catat, kedua-dua method Anda kena faham macam mana nak guna. Sebab kadang-kala kalau dia boleh guna method yang pertama untuk solve dia memang senang. Tapi kadang-kala tak boleh. Kadang-kala dia paksa juga kita guna method yang kedua. Okay, so Anda kena tahu kedua-dua method. So I give you 5 minutes to write it down. Meanwhile, I I will be away from keyboard for 2 minutes because my battery is low. I need to get a charger. Okay, so if you have any questions, you better post in the chat box so that I don't miss it. All right, I'm back if you have any questions.
Madam,
Yes?
theta kenapa ada dua?
Apa maksud theta kenapa ada dua?
Dia lebih tu sin theta tu.
Okay, now because after collisions, you have two objects, right? So theta 1 is for object 1, theta 2 is for object 2. So after collisions, what you'd have, if you look at the diagram, you have a 50 degree. This is actually the theta 1. Theta 1 is for object 1. And then object 2, because we don't know the positions, therefore we just write theta 2 because it is an unknown. So, all right?
Okay, madam.
I think you will have a clearer picture if you look at questions number 6, because questions number 6, the diagram shows you after collisions, two objects moving at different angle. Okay, because after collide, you don't know what is the directions of the second object. Therefore, we put it as a theta 2. So, all right, any other questions regarding this questions 5? So, questions 5 is a typical two-dimensional questions, right? Which involve an object moving in between x and y component. It's no longer vertical or horizontal only. Okay, it's moving at an angle. So, if it is moving at an angle, then you need to resolve it. So 5 minutes, time's up. All right. Okay, so next question. Okay, the last question, which is also a two-dimensional questions. All right. A ball moving with a speed that is initially with a speed of 17 meter per second. Now the keywords in this question, all right, a ball moving with a speed of 17 meter per second strikes an identical ball that is initially at rest. Now, what does it mean by identical ball? So when the question tells you two objects, they are identical, it carries the meaning M1 equals to M2. So in this case, we are going to use M for both of them, right? So after the collisions, the incoming ball has become deviated 45 degrees from the original direction. And the struck ball, it moves at a 30 degree from the origin of the direction as shown in the figure. So as you can see here, now, just now you asked me why there's two theta. Now, theta 1 belongs to object 1. In this example, it is 45 degree. Okay, so it belongs to object 1. Whereas theta 2, now you have 30 degree and it belongs to the second object. Okay, that's why we have two theta. So let's see, how are we going to calculate the speed of each ball? So now this question, it asks you to calculate the speed of each ball. We don't have V1, we don't have V2. What we do have is theta 2 and also theta 1. So let's see, how are we going to solve these questions? So again, let us begin with x component. Okay, x component. So x component, again, I'm going to start with these equations. This is what we call concept. So P initial along x component equals to summations P final along x component. So remember, this formula is very important because in exam, this formula itself is worth 1 mark. All right, before you solve the questions, as long as you write it down, you got 1 mark already. So summations P initial x equals to summations the momentum final x along x component. Initially, I have an object V1 moving at 17 meters per second. So M, okay, now I'm not going to write M1, M2. Why? Because both of them, they are known as M now. Okay, because they are identical. So if both objects, they are identical, it means M1 equals to M2. So to make it easier, I'm just going to write it as M. Okay, I'm just going to write as M. So M U1 plus M V1 equals to M. Now, if you look at my diagram, what I have here is a object moving at an angle. Therefore, V1x plus M V2x. All right. So when I expand these equations, now before I expand these equations, the reason why question give you the information identical is because it wants you to cancel out the m from the equation. So now you have 4m, they all have same value. Therefore, you can cancel it out. Okay, and therefore the next line would be 17 meters per second plus V1, which is at rest 0, equals to, now V1x and V2x, how am I going to calculate them? So you can leave it, but then if you leave it like this, it will be hard for you to solve the questions. So what am I going to do now? I want to expand the value. V1x is V1 cos 30 degree. Okay, V1 cos 30 degree plus V2, sorry, I make a mistake in my diagram. So this is not 30, this should be 1, this should be 2. So theta 1 is 45 degree, theta 2 is 30 degree. So V1 cos 45 degree and V2 cos 30 degree. All right. So let's see, how are we going to solve it? Now, when it comes to a situation like this, okay, when you have a value in terms of cos and you know the angle, I would suggest you to calculate the values of cos theta first. You don't leave it in a trigo function. Why? Because when students leave it in the trigo function, students often feel panic. Okay, panic. Like, oh my goodness, how am I going to solve these questions? It looks complicated. I got a cos theta, I got a sin theta. What should I do? Okay, so you can press the calculator and get the value first. So cos 45 degree will give you 0.707 V1 plus cos 30 degree will give you 0.866 V2. Yeah. 6. All right, 866 V2. So now it seems like in normal equations with two unknowns, your equations with an x and y in an equations, right? So now V1 is just like x, V2 is just like y in your mathematical equations, in your simultaneous equations. So now you have equations 1. Okay, and then let's look at y component. Okay, let's look at y component. So y component, again, so I have summations p initial y equals to summations p final y. So m, no, I'm not going to write initial again. Why? Because these questions obviously no initial y component. All right, so if you look at the diagram, initially it's moving along x component. Now, it's not always like this, yeah? Just at the examples given in your notes, coincidentally, both of them, they don't have initial y component. Sometimes you can have initial y component. So in that case, the equations will become m1 v1x plus m2 v2x. So you might need to resolve it before collision. So it could happen. But for these two example, the user's initial is equals to 0. Right? So it is equals to m1 v1y plus m2 v2y. So what am I going to do now? I want to cancel out the m again. Okay, why? Because m1 equals to m2 equals to m. So if you don't write the subscript, also can. You write the subscript, also can, but make sure you show it if you write subscript. So now I can cancel it out. Okay, I can cancel it out. So what next? So next, again, I'm going to expand my Vy. So 0 equals to, okay, V1. Okay, now let us go back to the diagram. If you look at diagram, V1, if I resolve V1, what am I going to get? So if I resolve V1, I will get X component going towards the right-hand side, V1X, and then I get a Y component going down. So which means this V1Y is a negative value. Okay, therefore, I'm going to put a negative here. So negative sign. Okay, negative. Okay, or I should put a negative in front of V to make it easier for you, not to confuse you. So, this is negative. So a negative V1, okay, negative V1 sine 45 degree, right? Negative V1 sine 45 degree. So plus, okay, now I don't know whether I want to plus a positive value or a negative value. Let me go back to the diagram. So if you look at the diagram, if you resolve V2, you get V2x along x component. Okay, and then you get a V2y towards positive direction. So in that case, my V2y is a positive value. Right, therefore, I have V2, okay, V2 sine 30 degree. So don't need to add negative sign in front of V2, right? It is now a positive value. So just now, what do I have? Okay, I'm just going to rewrite it in a more tidy form. So a negative V1 is sine, sorry, sine 45 degree. Okay, so this is before, not before, this is for object 1. So why is it negative? Okay, why negative? Let us see. So this negative value, it exists because of, okay, because of here. So it is going down. Okay, so it is going down. Therefore, I have a negative V1. Whereas when it comes to V2, because it's going up, therefore I use a positive value here. All right, next step. So like I told you just now, whenever you have a cos degree, cos angles, or sine angles, and you have the angles, you have the values for angle, okay, you calculate the value first. You don't leave it in sine or cos. So now you have 0 equals to negative, okay, negative what? So 45 degree again is a 0.70 V1 plus, so sine 30 degree, you will have a 0.5 V2. So this is your second equation. Okay, this is your second equations. Now that you have two equation with two unknown, so you solve the simultaneous equation. Okay, you solve simultaneous equations. So how to solve the simultaneous equations, I will leave it to you. Okay, matematik asas kamu cuba sendiri. So eventually you will get V1 equals to 8.80. Okay, 8.80 ms negative 1, and then V2 you will obtain a 12.44 ms negative 1. All right, so simultaneous equations, I leave it to you. All right, I'm not going to show you everything, so you try to solve it. Okay, you try to solve the simultaneous equations. So what I want to show you is that when it comes to this type of question, angle is a must. Okay, angle is a must. So you need to know, that's why I told you, you need to know the second method just now. So if you don't know the second method, if you keep it as a V1x and V2x, then you might have a more step to do. Okay, you obtain V1x, V2x. Oh no, you cannot solve it actually. Okay, because you have too many unknowns. So in order to solve this question, this step and this step, they are a must. Okay, you must know how to expand the equation. What does it mean by V1x? What does it mean by V2x? What does it mean by V1y? What does it mean by V2y? All right. So I give you 5 minutes to write it down. Make sure you solve the questions until you get V1 and V2. All right. Make sure you solve the questions until you get V1 and V2. So once you are done, you obtain the answer, then you may leave the class. So that's all for today. We are done with chapter 3. Okay. So if you have any questions, you may ask. So make sure you finish it first. Okay, jangan tak habis, salin sampai ikut saya bulat-bulat, and then kamu terus keluar kelas. No, make sure you try until you get V1 and V2. Okay, because sometimes the answer might be wrong. Don't always trust the answer. Okay, so salin-salin. Kalau dah siap, anda boleh leave class. Kalau belum siap, anda cuba sampai siap. Make sure you get answer for both of them. Because these two questions, they are considered as hot question.
Okay, madam. Thank you.
All right, good.
Thank you, madam.
Okay.
Thank you, madam.
Madam.
Thank you,
Okay.
madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Okay.
Thank you, madam.
Thank you, madam.